Good day! On the previous module, you learned about the process flow diagram of the raw materials. Indeed, the end is just the beginning. In this module, we are going to learn the actual processes involved in the production of borosilicate glass. Borosilicate glass, commonly known on its trade name Pyrex, is a type of glass with silica and boron trioxide as the main glass-forming constituents. Borosilicate glasses are known for having very low coefficients of thermal expansion, making them resistant to thermal shock, more so than any other common glass. In the actual process, natural gas is mainly the source of energy, while some processes use coal. Natural gas is a fossil fuel that exists in a gaseous state and is composed mainly of methane, a small percentage of other hydrocarbons like ethane. Natural gas is used due to the fact that it is the safest, cleanest, and most used form of energy in our daily lives. However, usage of natural gas also has its disadvantages. Natural gas is a non-renewable energy source and it is highly combustible. Mishandling can lead to bad explosions. With this, for safety purposes, coal will serve as an alternative source of energy for high-temperature operations like furnaces. Coal is chosen as an energy source because it is affordable, and it produces high energy upon combustion. For this module, the air emissions, wastewater, and solid waste will be mentioned, but their treatments will be discussed in the next module. The first step of the actual process is mixing. The raw materials, namely soda ash, borax HCl mixture, and silica sand will pass through a mixer to manipulate the heterogeneous physical system intentionally to make it more homogeneous. The mixer will use natural gas as an energy source. Using natural gas as an energy source will cause air emissions like carbon dioxide, carbon monoxide, NOx, and methane. Particulate matter will also occur in air emissions due to the gradual mixing of the raw materials. Mixed raw materials will serve as the product of this process. After the raw materials has been mixed, it will undergo crushing process. Crusher is a machine designed to reduce large particles into smaller ones. In the production of borosilicate glass, it is a need to crush the particles as small as possible, since it will be subjected to melting via furnaces. For this process, natural gas is also used as an energy source. Hence, air emissions like particulate matter, carbon dioxide, carbon monoxide, NOx, and methane will be emitted, and crushed raw materials will be the product. The raw materials has already been crushed, and they are now ready to undergo the melting process. The melting process is divided into two, the first chamber furnace and the second chamber furnace. The first chamber furnace will melt the crushed raw materials at 1550 degrees Celsius. The flames in the first chamber furnace burn so brightly that they cannot be seen without a filter. Inside the first chamber furnace, the crushed raw materials are continuously fed and are melted by intense heat. As more crushed raw materials are fed in, the molten mixture is forced to flow in the second chamber furnace through narrow vents. Notice that in the second chamber furnace, chlorine gas is pumped through the molten raw materials. Chlorine gas absorbs impurities and carries them to the surface. This makes the surface layer unusable for now, but of course, it is not yet wasted. Going back to the first and second chamber furnace, coal was used as an energy source for this process due to high temperature. Coal served as an alternative source for natural gas for safety, because natural gas may explode upon combustion and mishandling. With these, NOx, SOx, carbon monoxide, carbon dioxide, and VOCs will be emitted in air. Also, Chlorine gas will be emitted due to its usage on the impurities. Furthermore, alkali, borates, and furnace slag will be emitted as solid wastes. For the cooling process, natural gas will be used as an energy source. Therefore, particulate matter, carbon dioxide, carbon monoxide, NOx, and methane will be emitted in air. The pure molten raw materials will undergo molding. Molder is used to divide the pure molten raw materials and mold them into laboratory glasswares or coffee pots, depending on the desired shape. Chemical engineers take regular samples on the division of raw materials to check if the molder takes right amount each time. For heat-resistant glass, the raw materials will be as pure as possible. The chlorine gas removed any of the impurities, but the factory is full of dust and dirt, and so, workers should put on protective clothes while doing factory works and maintenance. Keeping the molder free of dust ensures high-quality glass. For this process, machines do all the work as the glass is way too hot for human hands to shape. Natural gas is also used as an energy source, causing energy emissions like particulate matter, carbon dioxide, carbon monoxide, NOx, methane, and VOCs. Solid waste cullet will also be emitted due to low-quality molded glass as inspected by the workers. The next process after molding the pure raw materials is annealing. Annealing is a process that alters the physical and sometimes chemical properties of a material to increase its ductility and reduce its hardness, making it more workable. It involves heating a material above its recrystallization temperature, maintaining a sustainable temperature, and then cooling. The three stages of the annealing process that proceed as the temperature of the material is increased are recovery, recrystallization, and grain growth. The first stage is recovery, and it results in softening of the metal through removal of primarily linear defects called dislocations, and the internal stresses they cause. Recovery occurs at the lower temperature stage of all annealing processes, and before the appearance of new strain-free grains. The grain size and shape do not change. The second stage is recrystallization, where new strain-free grains nucleate and grow to replace those deformed by internal stresses. If annealing is allowed to continue once recrystallization has completed, then grain growth, or the third stage, occurs. In grain growth, the microstructure starts to coarsen and may cause the metal to lose a substantial part of its original strength. This can, however, be regained with hardening. Coal is used as an energy source for this process. Therefore, NOx, SOx, carbon monoxide, carbon dioxide, VOCs, and particulate matter will be the air emissions. There will also be cullet solid waste in this process. After the glass has been annealed, the annealed glass will undergo inspection. This will ensure that the glass is of high quality and there are no cracks nor breakages once it was boxed and sealed for shipping. After the inspection, it will be sorted into two groups, namely, accepted glass and the rejected glass. The rejected glass will be sold to other glass companies and may be used as filler additives. Notice that the rejected glass cannot be recycled back to the start of the actual process. This is because, once the borosilicate glass is annealed, it is now completely heat resistant, meaning it can be exposed at high temperatures without breaking. Mixing it with the raw materials will degrade its quality. Hence, It will be better if it will be used as filler additives on ceramics. Inspection and sorting process also use natural gas as their energy source. Same with the other processes, NOx, SOx, carbon monoxide, carbon dioxide, VOCs, and particulate matter will be the air emissions. For the accepted borosilicate glass, it will undergo the final processes, namely batch testing, boxing, and sealing. Batch testing is done to ensure that the accepted borosilicate glass is of high quality and meet the industry standards. Boxing and sealing is done so that there will be no breakages during its shipping. For boxing, boxes that do not pass the standard will be the solid waste. Furthermore, adhesive materials like tapes will be the solid waste for sealing. All these three processes use natural gas as their energy source. Henceforth, carbon dioxide, carbon monoxide, NOx, and methane will be the air emission. I hope you learned a lot in the actual production of borosilicate glass. In the next module, you will learn the process flow diagram on the consumption of borosilicate glass. You will also learn how to treat the solid waste, air emissions, and wastewater using different processes. Thank you for listening and see you on the next module.